again and welcome back. So this video is about lesson 1.9 presenting results, tables and graphs. And the lesson is also represent a scientific method or scientific theory. So let's do more practice presenting scientific results. So let's think in a scientific way to present some of the results. So let's do more practice presenting scientific results. Turn to page 24 in your textbook and let's see. Suma is on a trampoline and reads that the weight limit for the trampoline is 120 kilogram, which is the force can be held by the trampoline is 1,200 Newton, right? If we multiply it by 10, the gravity, we will get 1,200 Newton. I will remind you that weight is equal mass times gravity. So the force that can be held by the trampoline is 1,200 Newton. This means that the trampoline is safe for people less than 120 kilogram. I want to ask you a question. What will happen if if a man or any people that is more than 120 kilogram? What will happen to the trampoline? Okay, let's figure out what will happen to the trampoline. Suma thinks that for safety, the weight must be much smaller. Read how Suma decides to test the elastic limit of a spring. First of all, here we have a keyword called elastic limit. What is the elastic limit? Any elastic object like the elastic band, the spring, the trampoline, any elastic object, it has an elastic limit. What is the elastic limit? It's the maximum force can be held by the elastic object before it spoils. So this trampoline, it has its elastic limit. If we just increase the mass so it will pass the elastic limit, the trampoline will spoil. How it will spoil? It will lose its elasticity. What the meaning of elasticity? It's that when you elongate something, it means that stretched. When you stretch something, it will come back to its original length. When it comes back to its original length, this is what we called an elastic object because it comes back to its original length. So, as a conclusion, the elastic limit is the maximum force. The elastic limit is the maximum force can be held by the elastic object. Let's see how Suma decided to test the elastic limit of a spring. She chose a spring. So Suma collects a spring, some weights, and a meter or a ruler meter, and draws a table ready for her result. And she drew a table. She's going to measure the weight as the extension. What is the extension? The extension is the difference in length. How it's when we put the weight on the spring, how much length the spring will extend. So I will repeat, the extension is that how much length the spring will elongate, will stretch. For example, if I bring a spring of length 8 centimeters, after I put 1 kilogram attached to this spring, it elongates 2 centimeters. So the extension is 2 centimeters. So what's the total length? The total length is 8 plus 2, it's 10, right? So the new length is 10. The original length is 8. If we subtract 10 from 8 is equal to 2 centimeters. This is what we call an extension. So the extension is the increase of length of the spring before I attached a force and after I attached a force. Okay, is that clear? So let's come back to the slide. She marks the length of the spring with no weight. So at the first, she's going to put the spring without any weight. Why? Because she's going to measure the length of the spring. As she adds weight, the spring stretches to a new length. When she adds weight, the spring will stretches or it will elongate. Okay? So what's the extension? The extension is the change in length. It will subtract the new length from the old length. For example, the new length is 12 centimeter, the old length is 8. So 12 minus 8 is equal to 4 centimeters. So the extension is 4 centimeter. I will give you an example. See the experiment carried out by another class in Suma's school. Let's see another experiment done by another class. So, this is a spring, okay? First of all, we put a weight of 1 Newton. The length is 2, okay? So, the first one, the length is 2, or the extension is 2, okay? And then we put, when we have the weight is 1, the extension is 2. Now, what we'll see if we put the weight of 2 Newton. When we put the weight of 2 Newton, the extension increased till it reached 4. So every 2 Newton, 4. And at 3, it's 6. So if I want to plot the graph of this table, I see a straight line. I see what? A straight line. Okay? If it continues as a straight line, it means that we didn't reach the elastic limit. If we start to see that there is a curve started to appear in that graph, so this point, the last point, represents the elastic limit. Okay? Now, this is a straight line. There is no curve. We didn't reach the elastic limit. Let's put the 4 Newton and see what will happen. If I put the 4 Newton, also, we obtained a straight line. There is no curve. This one is straight. Okay? So, 4 Newton is not the elastic limit. Let's see what will happen is if I put 5 Newton. And when I put 5 Newton, I see that a small curve start to appear. So that's what we call, this point is the elastic limit. Why? Because a small curved line appeared from the graph. But if I want to discuss what is the elastic limit, it's the last point can I reach by the spring before it loses its elasticity, or then after this elastic limit it will start to change its shape because it loses its elasticity. So if I deform this shape, it will be deformed. Okay, so if I deform this shape and it come back to its original length, this means that the elastic limit, I didn't cross it. So let's see let's see what we have, what we are going to obtain if I put 6 Newton. So if I put, before I put the 6 Newton, let us read this sentence. The elastic limit can be seen on the graph. This is where the spring starts to deform permanently. So this is point that represents that at 5 Newton is the elastic limit. After this elastic limit, the spring will be spoiled and it will lose its elasticity. What the meaning of elasticity? It will not come back to its original length. So at 6 Newton, it gives us 15 extension. So I obtained also curve, so it loses its elasticity. Okay, let's see Suma's experiment on page 25. Suma decided to draw a graph of extension against weight. The extension and the weight and extension are variables. Extension changes as weight change continuously. So both of them are variable. So the variables are called continuous variables. Suma plots them in a graph and draw the line of the best fit through the plotted point. At 3 Newton, please go to the graph page 25 and look at the graph and see at 3 Newton, there is a point, it's not in the straight line. Okay, What is this point? At 3 Newton, the plotted point does not lie on the line of the best fit. This is called an anomalous point. What is an anomalous point? It's the point that is not in the correct place. It's not in the straight line. So Suma probably measured the extension wrongly. So in this point, the measurement is wrong. I will repeat the measurement at that point to make sure that this point I will correct it. Okay? So when the point is out from the line, this means that something went wrong. I should repeat the experiment at this point. The best thing to do when you get an anomalous reading is to repeat it. Sorry. So I will repeat. The best thing that you can do it if you obtained an anomalous reading is to repeat it. Look at Suma's graph on page 25. What is the elastic limit on her spring? So look at that curve and give me the elastic limit, and I will leave this as a question. So the question is, look at Suma's graph on page 25. What is the elastic limit on her spring? I'm waiting your answers. Give me the force or the weight in a Newton that can be the elastic limit. For example, it's a 3 Newton, 4 Newton, 5 Newton, 6 Newton, 7, 8, whatever. Give me a point. I will name it as an elastic limit. Give me a value. Of course, I need a value. Okay, so this is the lesson of today. Please make sure that when you finish this video, when you repeat it more than one time, please go through the summary question and solve it. Thank you so much.